So has everyone got the links? Yep. Okay, so all data in Grasshopper has been stored in a list. So whenever you've actually looked at your information, right, you've been seeing lists of data. So everything in it is stored as trees. Yeah. The links. So you just need to download them. One of them will give you the link to the slides, the other will give you the link to the files you'll need. Still need them? Okay, so the list actually holds all the data. So the way lists are stored are called trees, and the way they're stored are called branches. So when you operate on different functions, it'll try and read the structure of the branch trees, and based on the structure of the trees, it'll perform the operations. So there are several operations you can run on trees, and they're flatten, graph, trim, and simplify. So open up the file that I linked, and you'll notice here. So I'll start down here. Okay. So,
how do you open a Grasshopper file?
So you just go into Grasshopper from command. So up here in command, you can type Grasshopper to open Grasshopper. And once you're from there, you can go File, Open. Or drag and drop it in. Open?
Sorry, I was using the wrong rhinoceros. I was using the old one instead.
Can you open Grasshopper? So you can then just go to Grasshopper. Have you installed Grasshopper?
Wait, did you have the right rhinoceros?
Yeah. Wait, this is Windows. This should have all your set. So just open the file from here. Working?
That's my first week here, so
Okay.
just
Download? Yep.
You guys all good? My files will be
So which file? Which file? Yeah, so you need
this one I
you, not this one. The links. So when you go to the slides, first slide, one of them will be a link to a file. Should be that one or the other one. I can't remember which one. So one of them will be files, the other will be link. This is the Mac, right? Yes, because the Mac one is you need the work in progress version for the Mac, and that has I can't tell if it works properly or not. Okay, so basically this is what a normal list looks like. It's flat, and it'll just have a series of numbers from 0 to 9, and it'll have an index for each number. So one of the operations for numbers is you can graph them. So when you graph, you notice that suddenly this tree suddenly becomes a lot bigger, and that each number has its own branch. It's separated each number individually. So when the point actually reads it, it'll try and match one branch to the next branch. So this branch will then be mapped to the first branch. It'll then map this branch to the second branch, and map this branch to the third branch, and so forth, resulting in this. So the first item, along with this entire list, forms this list. However, if we say graph the next one, it'll go match the first list with the first list, the second list with the second list, and so forth. So that's how it works. So the opposite of grafting is to flatten, and that'll just undo all the changes here. And I'll just bring it back. So an easy way of creating a grid is to actually just use a series and just to graph one of the inputs and not graph the other. So something like this. As you can see here, you're still using the same set of numbers here, but for one of the inputs, you've graphed it, changing the structure, while you haven't changed the structure of the other one. Okay. So, a bit too fast. Okay. So here I've created a random number of random numbers of random numbers. So it creates a structure sort of like this in terms of numbers. So each branch will have, okay, the first one generated a random set of numbers, which was 4. Generate 4 random numbers, and then the next one generated another set of random numbers, creating a random number of branches here. So the first operation I applied was flatten tree, and what it does is it changes the numbers back into the same list. So it takes this whole list of numbers into this list here. Graphed will mean that each number will be separated into its own individual branch. Trim tree will cut down the end number, so it will cut off the last number, resulting in the ends of this tree shortened. So you can see here, it's just taken all the edge ones off, and it results in this. And then simplify removes all the excess zeros, so it basically just removes these 2 points here, creating this tree here. Okay. These are comparators. You can use them to compare different values. So you may say you want to check where the length of a single line is longer than 5. And so you have a series of lines, you can get their length, and you can just compare them with a null number, and you can get a true or false value based on their comparisons. So these are standard AND gates, not OR gates and NOT gates. So based on the true false, you can get different values. And so you can use it to test whether things are multiple different conditions are met when you're checking your numbers. And then based on these values, say you have a list of true falses here, and you feed them into a dispatch. It's sort of like a programming if statement. So it'll figure out this based on the conditions tested here. It'll test these numbers and split them according to 2 separate lists, a list of trues and a list of falses. And then using weave, you can merge the numbers back together so that you have the original list remade. Okay, so I'm going to start into the main topic of today's lessons, which is how to create a Waffle script. So a Waffle script is basically a way of taking a 3D object, slicing it up, and being able to 3D print it, and then put it back together again by slowing it together. So the first thing we're going to need is some sort of solid to work on. So I'm just going to create several shapes. So sphere.
How do we delete any weird shapes created when we were messing around with those lines earlier?
Which one? This one?
Yeah.
So they all exist in virtual space, so they don't actually exist in Rhino.
Oh,
So these are all virtual, so they do not exist in Rhino. So they're not actually physically made.
so if they're red lines, they're not physically made?
They're not physical.
Okay.
Any red or green, so when you select it, it turns green.
Okay. So how did you create that sphere then?
This sphere is not real. It's a still shape here.
Oh, okay.
So I'm just going to create a sphere, and it's a location and the radius of the sphere. So we want to create a relatively large sphere, say a 400 radius sphere. And I'll just create 5 of them. So here's point, construct point.
So where do you put into the X?
So by putting a series into an X, right? So I can create a set of points at those locations. So I'm just creating several spheres chained together, like that, as just a shape. So the whole point of Waffle is you take a single shape and then you turn it into something. So it's any shape you want. So say we have our tree, that could be the shape we make. And this is just just the basic shape that we're going to use for the purpose of this workshop. So that. So this is a container for a boundary representation, or Bierut. So it's just basically any solid, or well, open solid, but almost any sort of geometry can be put into a Bierut. And so we're just going to use that as a temporary storage point for this object. Wait, first before that, we're just going to go solid union. So, yeah. So in Intersect, you're going to find a few items called solids. So these are a way of cutting objects out of each other or joining objects together. So say you've got 2 boxes that you want to join, you can use a solid union to join them. Or if you want to cut shapes out of other shapes, then you can use solid difference. So we're just going to join the spheres together to make one solid object. Any problems?
How do you, like, when
Yeah, you zoomed in too much. The size is too big. Zoom out. Yes.
Oh, wait, oh, okay, no wonder it's where.
Yeah, Chris, how do you group? So you know how like you put the root variables just to define how you group.
Okay, so let's go. Have you? Okay. Series construct point sphere solid union. So how do I group stuff? So you select the things you want to group, and you can go right click group. So you can select an object that you don't want to group, and you can go remove from group, or you can just completely ungroup the entire thing. Yeah. Okay. So once you've got that, we've got our Bierut, which is the shape that we're going to work on. So I'm just going to select all the previous stuff, and I'm just going to turn them off. preview off. That way we can't see them anymore. So that's the object. So what we're going to do is first of all figure out how big our entire object is, and we're just going to do that by using bounding blocks. So what bounding blocks does is it takes a series of objects. Do you need me to go back?
Oh, yeah, please.
Yeah. Can you read that? Construct point, sphere, solid unit. So what bounding box does is it takes an object and it builds a box wrapping the entire object. So as you can see here, there's now a box that surrounds the entire object. And so it figures out how much space the actual object takes. So with that box, we can go deconstruct box. And we can take the box apart to actually find the X, Y, and Z sizes.
What's the difference between the two box sliders and the bounding blocks?
Which box sliders?
Like the two B's, just
Okay.
the words they just both say box.
Box.
Like, is there a difference?
Align bound. Okay, so here you've got the plane, right? Which is a sort of, you can rotate the XY planes. And this one will be on the world coordinates, which is the world XY, which is 0, 0, 0, normal. However, you feed a different plane in, this one will give you a different result. And that'll just be rotated according to your plane. So going from here, you can go X, Y, Z. So what we're going to do is we're going to go range here. So from last time, range allows you to take a set of limits and divide that into a set number of points. So say we have a range of 0 to 10, we can divide that into 10, so that'll be 0, 1, 2, 3, 4. So what we're going to do is take the X, and we're also going to take the Y, and we're just going to divide it into, say, 20. Let's go 10, might sound more reasonable. Say 30 and 10, so that's how we'll divide it. So as you can see here, it's got a set of numbers from -400 all the way to 2776. And then here we've got a set of numbers from -400 to 400. So the next thing we're going to do is, if we try and create a plane at the end and at both ends, they're just going to be really horrible circles and they won't actually work too well, so we're just going to remove them. So you can go in sets, you can go, where is it? Cull index. So cull index, what it does is it takes a list and removes the index items. So if we say we want to remove the first and the last item, we just tell it the index that we want to remove, so the first and the last, and it will remove that item from the list. So, number. So what we're going to do is we're going to create a number container, and inside we're going to go set multiple numbers. And the numbers we're going to set are 0 and -1. So,
Sorry, how do you set the numbers?
right click the item and you can go set multiple numbers.
Okay. So you just press enter.
Yep, once you've set it, just press enter. So what this is going to do is it's going to remove the first and the last item. So with the way Grasshopper works is it wraps stuff normally. So since wrapping is true, -1 is the same as the last item, and so when you count 0 to say 10 item, 0 to 10, once you go to 11, it'll start back from the beginning again. And if you go to negatives, it'll start from the end and go backwards. So when you are selecting items based on a list, say list item or col index, it'll always wrap, so you can go select the last one by always saying -1. So we want to do the same for the other range. And that'll say remove the first and the last. Have I lost anyone yet? Yeah.
So I just installed it.
Yeah, so to actually add items, you can double click and you can find the item and you can just add the things in. So, do you want to just copy this stuff
Yeah,
up to that point?
I think Crash starts already doing everything.
Yeah. Just say frequently.
Yeah. It's just this bit here. You have to create a point, right?
A series and then a
A
point.
series and then a point.
Yeah.
Did you make it?
Point construct point.
This is make
So you don't want the boxes to be that bulky, you can go display. Yeah, that's restricted down. That's the radius. You want a larger radius. Look, if spheres are at 58 millimeters between them, and then each one millimeter small. So they're very far apart, and they're very small. So you want the radius so that the balls overlap. So you want the balls to intersect with each other. So zoom out a bit. So yeah, you want objects that actually intersect and join together. Okay.
So do we make it down then?
Make what?
Make it anywhere.
Yeah, you can make it anywhere. So this is your entire canvas.
Oh, okay.
They've just created this box top left corner to make it neat, but you can just build your entire script anywhere. So we're gonna move these along the x coordinate. So I'm gonna move these along the x. Is it x or y? Yeah, x. And I want to move the other ones along the y coordinates. So these are now y coordinate values here. And these are x coordinate values. Have I got them in the right direction? Orientation is the problem. Okay, so what the unit x does is it takes a number and basically constructs a point on where the x value is the only value you read in. So as you can see here, it constructs a point at the x value, 0, 0. And when I feed that into a plane, it creates a plane at that point. So I want to create a YZ plane at those points, so that when you see here, you can see that these planes here run parallel to this face here on the box. So for the y values, you want to create x, z, z. and they'll create these planes, which run parallel to this face here. Peter?
Yeah. Also, is anyone here on the research for sensors? Okay, go on.
Okay, who wants to get food or who wants to continue with this? Or should I just get the pizza in here? I'll go grab 2 pizzas. I'm gonna grab 2 pizzas.
If you don't do this one, there'll be like a special.
Yeah.
Yeah. We only ordered 2 different types of pizzas, so. What you do is you take a lid. Yep. And you just grab the pizzas you want. Now don't worry, we can have 1, 2, 3, 1, 2. We've got 6 piece? We've got 6. Yep. Yellow. Okay, so this has no number in it, so you first need graphics set number 0, which is the first item, -1, which is the last item.
That's why I don't like it.
Okay. And then because of that big number here, you'll like it. So your range has an empty number, so your domain is correct. Your steps is 0.3, that's way too small. So steps is the number it takes it to write it. So what the range item does is I have a range, say 0 to 10, right? Say that's my domain and my n is my number. So if I have 5 there, it'll take it and divide into 1, 2, 3, 4, 5. So if I feed 0.3 in, it's not going to be able to divide it. And that's going to cause an error. So what domain does is you feed a domain, the range does, you feed a domain, which is this limit. You feed n, which is the number of divides you want. And then it'll give you 1, 2, 3, 4, 5, 6. So it'll give you n plus 1 numbers out. Color index, right, is then going to take this list of numbers, and because the number we're going to feed is 0 and -1, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It's going to wrap. So 0, -1, -2, -3, -4, -5, -6, -7. So with the way the numbering system works, is 0 to whatever number, next number, all the way up, or you go backwards and you go there. So when you look through lists, the numbers always wrap and it goes back around to the beginning again. Next one, the unit X, it's going to create points. So when you construct a point, we normally give it 2 or 3 numbers, right? Here, if we just use unit X, it's just going to give it a single number, and that number is going to be in the X spot. So it's the same as using a construct point, and only feeding this number into the X, and that'll give you the same result. Then go into the X, Y, Z plane. It's going to construct planes that are in the YZ direction. So here you can see the YZ here. So it's going to construct a plane that's on the YZ direction, and it's going to construct it at these points here. So the next object we're going to use is a Bierut plane. So what it's going to do is it's going to take a boundary representation or an object and see where it intersects with a plane and create a curve. So taking these planes, we're going to take the original bound shape that we had, and it's going to form these curves here. So these green ones are the curves that form. And doing the same for the other way, you now have this, which is essentially a grid, if you look at it from the top. So when we send to the laser cutter, you're going to have discs, right? And you're going to laser cut them out, then they're going to slide to each other like this, and it's going to form a 3D skeleton of some sort. By the way, have I actually shown you what we're actually making? Yeah.
You did last week.
I think so.
Oh.
So basically this.
How are the lights being put into that?
So we're going to be putting some lights inside these holes, and there's going to be lights on the leaves around it. So there's going to be a lot of leaves on top, and we're going to put lights interspersed with the leaves. So, okay, let's see if I have the model. Okay, right. So this is a 1 to 1,000th scale of the tree. Because Jonathan made a mistake in the dimensions and put in meters. So let me see if I can get. So the tree is going to look sort of like this. I can't get a good. Yeah, I can't get a good view of it. But it's basically going to look like, yeah, this tiny thing, except a lot bigger. So you can take any object, and basically what we'll be doing is taking the design of the tree, and we're just going to feed it into this B-rep shape here. So once you've got these planes here, you've got different things to work with. So I'm just going to hide these. So once you've got the plane, you can go edge surface, boundary surfaces. So what boundary surfaces does is it takes a outline, say you have a line drawing outlining the shape, and what it'll do is it'll fill in that shape based on those outline. So we're going to take these curves and we're going to turn them into that. So do I turn all these off so we can't see them? you begin to see the structure forming of these individual lines.
How did you turn those other cameras off?
Just go select what you want to turn off and go right click preview off. So that'll just stop the display.
So do you turn off everything else?
Yeah, I just turned off everything else. However, if we were to just take these circles and chuck it in a 3D printer, I'm pretty sure it's not going to fit together because you need cut holes for it. So to actually join it together, we need to figure out where all these cuts are. And so we're going to go take these surfaces and we're going to intersect them with each other. So Brep to Brep. So what it's going to do is it's going to take two planes and intersect them. So we can go A to B. However, as you can see here, that the resulting lines are, these are the lines of intersection. Okay, we're just going to duplicate them. However, they're not going to work because they aren't actually intersecting each other. So what you need to do is you need to flatten them both.
So flatten the boundary surfaces?
Flatten both boundary surfaces. That way, you have all the boundary surfaces on the same level, like this. However, with the way it maps it, okay, it's not going to map it correctly because it's going to map the first item in the list to the first item in the other list. However, what we want to do is, for the first surface to figure out where it intersects all the other ones. So what we want to do is we need to graph this. So what it's going to do is it's going to take the first surface, it's going to now have something like this. So as you can see here that each item in the list is its own list. Well, each item here is in one giant list. So what it's going to do is it's going to take the first item of this list, first list, map it to the entire list. Second list, map it to the entire list. Third list, map it to the entire list. So when you have a look at branches, you can say this one contains 5 items, this one contains 4 items, this object contains 6. You can have another. I swear I definitely need air markers. So 3, 2. So say you have something like this, right? So this list is your first boundary surface, this list is your second boundary surface. What it's going to do is it's going to take this list and map it to this list map it to this list, and because this one has nowhere else, it's going to map it to the last one. The same for the inverse. And then, once it's done that, it's going to do the insides. So it's going to take these 5 items, and these 3 items, and it's going to do the calculations according to this order. So what it's going to do is it's going to look within the list itself, and then map the longest. So what we need to do is make it so that the first one is each item is its own list. So what we end up with is something like this. For the 5, and then for the 3, since we've flattened it up there, it's going to end up with something like this. Which that means, since there's going to be 5 items here and 1 item here, it's going to map each one of these items to that list and join them all up. So the same can be said for this one. We need to invert flatten this other one. So the main result you see from these are the curves, which is the curve which you get from the intersection. So we turn them all off, that's what we get. So these are the actual intersection lines that we form. Okay. So next up, we are going to need to trim the trees. Yep. Okay. So this one. It's got the numbers here. This is definitely a result. It's not algorithm for results. Oh, you've locked the solver. So what lock solver does is it stops it from computing, so the computer stops calculating. So if you just do something to accidentally crash your computer, what you want to do is you want to open up, when you reopen Grasshopper, you right click, lock solver, and that stops the computer from calculating any further results. Then you can reopen your file and try and fix your file. So do not, if you create your file, make your file crash your computer, do not just open it again. Make sure you right click, lock the solver, then reopen it. So it basically stops it from computing, so the computer will actually do no more calculations. So the computer will not register any values because it's not going to read anything. So it just stops the CPU from doing any further actions. You know that it's in lock mode by the red border around your entire thing. Yep.
Where did you connect to the top of the plane to?
Which one? This one?
Yeah.
So B is connected to the B-rep. So B-rep is boundary representation. So if you're having trouble figuring out what is what, you can go draw full names here. Display draw full names. So we're going to need to trim the tree here. So as I said earlier, trim tree is just going to cut the last item, cut the last number off this list. So it's just going to erase this entire column of numbers there, and it's just going to form a list without those last numbers. Like that. So if you don't trim the tree, it's going to look like this. However, it's going to remove the last number. So all these items are just going to be put into the same list with this number here, resulting in this. Okay, so the other option to trim tree is D, which is the depth that you trim to. So if we were to feed, its default is normally 1, which you can see here, it calls the last number here. However, if we trim it down to 2, you'll have removed all the numbers, resulting in them all in 0. Trim it down to 3, and you have absolutely no results because it cuts the tree too far. So basically, we want to trim it to the depth of 1. So when you're working in really large trees, you're going to need to figure out how far to cut your tree down. So that's something you'll need to work out when you're working on it. So the next function we're going to use is list length. So you have a list and you need to know the length of the list, so this is going to give you the length.
Why is it that some of your lines are dotted and some of your lines are filled in?
Okay, is it showing up like that in yours?
No, they're all just grey. I'm just wondering what the difference is.
If you go display, roll and see wires.
Maybe it's a
Yeah.
I'm just wondering what the
Yes.
We ran out of pizza.
You can take half of it. Take the box and take half of the pizza. You might just need to shake it up like that. It should be fine. Yeah, I'll check out the end. If it's not working well, then working?
Yep.
Manage to get up to here or still far behind?
Oh no, like, I don't know why I'm doing this orange.
Like orange?
Yeah.
You never work it out, mouse.
This is like hell.
Oh, that's so slow.
Oh yes, yeah.
Okay. The number? Can you write that number?
Yeah, I changed it to
Set multiple numbers. Can you change it? Okay. This. Oh. Right click, enable. So can you enable that? Yep. So what you did was you disabled an item. So in your debugging scripts, you want to disable stuff, or when you don't want to run certain functions, you can disable them.
Sorry.
Yep.
So when I hide this layer,
Yep.
I can see.
Quick reading. Yep.
What's that?
That's used for debugging. So I'll explain that when I get to the front. Okay. So I got a few questions. So the first is these wires here. So if you're on the Mac work in progress version, they're going to look like solid wires, but if you're on Windows, then they're going to look like this. So there's basically 3 different types of wires. There's the first one, which is this one, which is a single object. This one here, which is the 2 lines, and that's going to mean it's a list. And then here, when it's dotted line, that means it's going to be a tree. So it's just an easy way of seeing what data is coming out of what. Next is this option here. So if you enable this, then you can't see anything unless you click on it. So it's a good way of searching through your functions and finding the results of what you were doing. But it can get really confusing when you can't actually see what you're doing. So yeah. So next is list length. So you can see here that the first item has 5 numbers in the list. The next one has another 5. The next one has 4. And what list length does is it's going to check each list and it's going to output the length of each list. Like that. Okay, right. Wrong item. Oops. You meant to take the list length out of the surfaces. So out of these two. So basically we're trying to find the number of planes that we made. So we're just going to check the number of these that we have. And now we're going to okay, we're now going to create a series of planes. Yep. So we're going to create a series of points. So start, and we're going to just feed a really large slider here. Into the number. And then we're just going to construct a point. So what this is doing is it's constructing a set of points. At these locations. So it'll construct a point at, say, this number, and we've got 2 sets of points. So what we're going to do is we're going to take these surfaces and we're going to place them onto these points. So we're going to take, not the surface, the curves. So this set of curves will be oriented onto this set of points. So we're going to orient. So what orient does is it takes a geometry from a original plane that it was in, and it's going to map it to a new plane. So we're going to take this set of curves, and this set of curves was created from this set of planes, so that's the original plane, and then we're going to map to this set of points. Now, as you can see here, the desired result is not what we want because it's going to map each item in that list to each item on here and this one. So what we want to do here is we have 9 branches on the tree, we have exactly 9 planes, and we have exactly 9 target planes. So what we want to do is we want to graph this. So it's taking the curves from the Bieruts and the planes here. So these are the curves that these curves here that we generate when we cut the plane with the circles. And then these were the XY planes that generate. So as you can see here, these planes will line up with these curves. And so we'll orientate them. Okay. Yep, so we're just going to increase this number until it does not overlap. These things don't overlap. So as you can see here, what we've done is we've just taken the cutouts and moved them onto the new positions. So real thing, it's just these two are fed into the top and the bottom. So the reason why I actually didn't flatten this list and just use it as is because each branch of this list has a different number of items, and so if I actually flattened it, I would have ended up with the curves moving all over the place, because it will then map these items into the wrong curve. So doing the same for the other set of curves. Geometry, original plane, and new target plane. Get this. So you can see here all the circles. The next thing we're going to need to do is take these lines here.
Did you need to feed a y coordinate into the construct point at the top?
For the top, no, since they're all along this y equals 0, while the other set is along here. So this one has a y coordinate. The other one is, if you don't feed it, it'll just go y equals 0. So we just need two sets of numbers that we can map it to.
Between the green X and the red X circles there, how did you increase that distance?
I just better slide into the y, because this point here is y equals 0. So this whole series of points here, which is this whole set of points along here, are all based on the same y value. So if I increase that y value, it's just going to move the entire set across in the y direction.
Oh, okay. Cool, thank you.
So now, as you can see here, when you look at these circles, you can see all these vertical lines, right? And so we need to move these lines onto the same planes of the circles as we had them. So we've got the lines here, and we're going to need to orientate them onto the new plane again. So, do you guys want to try that? So, yep. So we're just going to move these lines onto the same planes as the circles, so that we get the same thing as this. You can see it's a circle with vertical lines on it. We make it so that these circles also have the same vertical lines on it. Okay, so you're going to increase the number. The other thing is, have a look here. So your geometry, right, is not mapping to this. So what it's doing is, the first item here, it's going to take all these values and all these values. So what it's going to do is it's going to create 9 different results, all on the same point. So for each one, it's going to create 9 results. So what we want to do is we want to graph these so that there's one result per geometry. So you can see one item. Yeah. You can see one branch there, and you can see the branches look the same. And so you want that. Your current problem is that this value is too small. You make this number larger.
Okay, and that's for the step between.
Yeah, the step between these 2 points here. That's the distance from there to there. You can just increase that. Yeah, so have a look at geometry, have a look at the weighted geometry shape. You see the way it's shaped with branch, right? The tree's shaped like that.
What do you mean?
As in, you look at the numbers, right?
Yeah.
You can see that out the front there's 9 of these lines.
Yeah.
However, here, there is none, there's only one single line.
Yeah.
So what you need to do is you need to graph these so that's a 1 to 1. So you can see that it matches. That's how you ensure that your data is operating properly, so you need match them. So now try and figure out how to move the lines across. So, wait, what? Okay, that's funny. Oh, you've got another one here. Okay. Yeah, really. Okay. Yeah. Okay. Yeah, never a model without mouse.
Yeah, we're trying to figure out each component for
Okay.
for this one.
Yeah. So if you're looking for something, right?
Yeah.
You can double click and you can start searching.
Yeah.
So the name of each item is actually written in the box above it. So you can see above each box there's a label.
Yeah, and also I'm trying to figure out what's the function.
Deconstruct box.
Yeah, each
What each one does.
some of them. And
Okay.
The graph, I have no idea what is graph.
Bierut is boundary representation. It means a solid object, or it can mean the surface. It's just any sort of object that's got a sort of surface to it. So it's a closed cylinder. It's got edges, and it's got surfaces. So anything with a surface to it is a boundary representation.
And now you have these, this creates the sets of circles, right?
Yes.
And then now you want to, you're oriented.
You want to do your lines. You know how the vertical lines that we created?
Yeah.
Map them onto these circles there.
Can I ask why the graph this one between these two?
So Bierut that one's a container.
Yeah.
So that's just a way of me separating this part of the script and this is the new part of the script. So that Bierut, you can use it to import geometry from Rhino into the script. So it's basically just a way of me saying that this is the object, and it's going to go into this box next. Yep. Yeah, that moves the Y direction. So we just need them separated so that when we laser cut, they don't overlap. When you're laser cutting stuff, you do not want your things on top of each other when you cut them. Yeah, you just need a small space between. You don't need that big. Okay, so so you see these ones here? Object. That's just slices through your material.
So there's like line slices in the right direction.
Yep. Well,
And the circle is the
this direction, and then so we look at it from the top. These direction, right? Are all these circles here?
so these are the ones that goes like that, like vertical.
Yeah, and then the horizontal ones are these ones up here.
Yeah. Okay.
So we have these lines. How they aren't on here yet, and so we are going to orientate these lines onto these surfaces. So can you orientate them?
Sorry, can I just ask, I increased this number slider to get the distance between these two circles, but it didn't apply to the copy circles.
So that circle there is. Do we have the top view? It's not top view. So as you can see here, that's the distance between these two circles.
So, yeah, so they were really close, and I increased that number to get the distance bigger, but it hasn't been repeated in the lines.
But you can see here, the first set of circles is here. The second set of circles is this line across here, which also intersects all these. So you can see here that this is still one object because we merge them all together. So it's one giant chain of balls. So if you keep increasing them, then they'll start to separate, but then you'll run into a separate issue, which is basically this trim tree. You'll need to start changing the D value to actually get the proper cutting down.
Okay. I thought we wanted them separated, so that...
No, it was one giant chain.
Okay.
It was just to show you different objects, so if I just made a circle, it would have looked. So has anyone actually managed to map these vertical lines onto it? Yeah. Just copy it.
Yeah. So you're orienting this surface.
No, the lines.
Are you going to send
These
by email?
curves that you get out of these.
Wait, how do you
Yeah.
measure it?
And you're going to try and map them onto the
Oh,
new
right.
surface.
You can save first. Oh, you just. Yeah, I'm just trying to right click. Oh.
These canvas have other like function there.
right click, preview off. That means they won't show on here.
Oh, is that the real tree that is
So once we have the tree right,
Yeah.
we'll just feed it into this beamer. So we can just change this entire thing to the object that we want.
Oh.
So I was just using this to actually just create an object that we can work with.
So
It's
what's
using
the,
it.
yeah, so what's the source for this? Because you have the Bierut codes that create the geometry.
Yes. Do you guys have this rule book? Oh, there's a class at 8? Okay, yeah, okay. Because this workshop is meant to be at 8 o'clock. Okay, we're out here in 10 minutes because the class coming in. Okay, so I'm going to have to show how this is done. Okay, we have less time than we thought. So what we're going to do is take this geometry and map it. So let's see. This is 0 to 16. So 18, yep, that's the right one. So basically what I'm doing now is currently just checking the list length. So this is 17. So we know that it should be to these 17 points because that's the only other one with 17. And so we want to take the original, which is 9 values here, which is not right. 17. 9 values. Nine values. Wait, 20. Something's not matching up. Give me a moment. Sorry. Nine values. Oh, oopsies. Yeah, that's why. Okay, this makes a lot more sense now. Okay, so the list length was meant to be connected to the planes. So it should have given me 9 planes, 9 values. That's why it wasn't coming out properly. And from there, we can go mapping to these points here. The trim tree list. So it's given us, 16. What have I done wrong? I've done something really wrong? I can't remember. Listing plane. Why did I go flatten? Oh. Oopsies. Yep. My mistake. So basically I made a mistake with the actual thing, so it's meant to be graphed here, flattened here. Where does this get me? Simplify here, simplify here. Yep, that gives me the correct number. Okay, my mistake. So it was meant to be graphed, graphed, flattened, flattened, simplify, simplify. Eight. Simplify, trim depth. And then, yeah, this is where you need to be careful. So, you need a depth of 2 here. So, as you can see here, there's 3 sets of numbers, 0, 0, 0, 0, 0, 1, all the way up to 8, 4, 28. So, what we need to do is cut it back down to 9 items. So, that's why we need to trim a depth of 2. So, we basically erase this set of numbers and this set of numbers, and we have 0s to 8s. And that'll give us this set of numbers here. And that's what we want to feed into this geometry. And then for the other set of geometry, we want to map it to this set of points here. And that'll get us to here. Confusing? Yep.
Sorry, so the one with the tree, the orange, the source and target are still the same?
The what?
The source and target are still the same as the ones before? Or are they?
The which ones?
The 2
The
new orients.
new orients are, well, these two are the same. However, the geometry will be these 2 points here.
Okay, so alright.
So they're fixed to the new geometry. Make sure you take note of these graph, flatten, and simplifies. I completely messed that up. I'll go over 5 minutes. I don't think I'm going to finish this today. Okay. I think I'll set the end here. However, I'm going to set a bit of homework. So, you saw how we had the planes as crisscrossing in the X and Y direction, right? So, if you take it to the third direction, you can create a triaxial waffle. And so you can create something like this. So when you look at it, it's like that, right? So all these are based off these sets of planes cutting them. So we only have 2 sets of planes. What happens if we have a third set?
Yes, are you aware that it's a
I know,
class-
give me 5 minutes. So what happens if we have a third set and we continue intersecting them? That should give us 3 sets of cuts to make. So as homework, I'm gonna let you try and make a triaxial waffle.
Okay, I'll play that for us and your.
This script?
Yeah.
Yep. Okay. Yep, so I'll end this one here.